So today we're going to talk about dora-rs. It's a project we've been building for 3 years. And yeah, I think it's exciting. So basically what we're trying to do is make AI robotic very simple. Maybe just to put a bit of context, there's been a lot of progress in recent robotics. So a lot of things that used to be very hard, like folding clothes, can be now done with deep learning models, such as ACT model, which use imitation learning. So basically what you do is you collect a lot of data from people, and then you're able to create a model that is able to predict the movement of the robot given the data that you've trained on, right? So in this case, they use like a humanoid robot to fold clothes, and is also able to fold clothes on unseen object, right? The thing is, like, this robot costs a lot of money. It's from Stanford. They have a lot of funds. And we want to make it very accessible so that anyone can get started. They also have a lot of engineers, so we want to make this whole thing a lot more simple, right? This is another example, so with robotic arms. And so this is already a lot more affordable. This only costs about $30,000. And they're also able to do imitation learning and train policy that is able to do tasks that used to be very hard. But now it's just an end-to-end model that is able to do those things, right? And so this is kind of a paradigm shift between before. In the past, we used to have like robotic applications that used to be very complex. You used to have a lot of different blocks of different capabilities. So for example, if you want to build like a robot that is able to navigate terrains, roads, you will probably, in the past, you will probably have a lot of different blocks to detect things like roads, road signs, traffic lights. And this used to bring a lot of complexity. But nowadays, we can just have a very big AI model that is able to take an image and be able to create an action, right? Kind of like VLAs. And so you don't need all the complexity that we used to have in previous generation of robotic software. You can make it very simple, right? This is another example of a project called AutoWare, which is basically one of the most advanced open source projects for autonomous driving. It used to be extremely complex, right? If you wanted to learn this, you would probably need a couple of months, if not years, to really understand everything to be able to drive a car. But now with imitation learning, you can just collect some data and train a model, and then the model will be able to navigate roads and terrains, right? So this is kind of the idea. But the thing is, to make this very simple, we have to completely change the robotic stack. We have to make it very simple, very accessible, so that anyone can get started. So we removed a lot of the complexity from previous generation. We removed a lot of the serialization, deserialization to just use very simple, basic data type, like images and audio and text. We removed a lot of the latency by doing this, because now everything is just very simple, basic data type. And we're really trying to make it very easy to maintain and debug, right? And so in this way, we think that we can make it very accessible for anyone to get started in the weekend, for anyone to get started on any type of application they want to do, right? Even though they're not expert in autonomous driving, they will still be able to build autonomous driving vehicles. All right, so that's why we did Dora, right? Our goal is to make it very accessible. The use case is just like real-world problem solving with kind of like DIY robotics. So in this case, we built our own robotic car with the Chongqing University. Everything is mostly open source, so you can build it at home. It costs less than $10,000, and you can run it for a couple of hours without an issue. You have a robotic arm that I'm going to demonstrate later, and so everything is going to be very easy for anyone to get started, right? And hopefully we can target different communities as well, right? From the very experienced PhD students to the very simple master student, right? Or like even just people at home, even children. So, okay. So how do we get started, right? The idea is that you can in one line, you can install Dora. And so once you install Dora, you can just build data flows and run them, right? So I've already installed Dora in my computer. But if I want to start, for example, a VLM demo, I can just Dora build a data flow, which is going to install all the different dependencies that I need, and then I'll just be able to run it, right? So I can just do Dora start, data flow. In this case, I'm using rerun. And then once it's started, they're going to be the demo that is going to pop. And now in this case, I'm using a VLM. And the VLM is able to tell what he sees in the image, right? So for example, if I do a heart sign, it's going to say heart shape, right? If I do a peace sign, it's going to say man in peace sign, right? And so this is fun, this is cool, but it doesn't really do much. And the idea is, how can we make this useful, right? How can we transform this description into an action that we can use on the robot, for example? So to do this, okay, so before doing the demo, I'm just going to quickly highlight that this works on all languages, from C, C++, Rust, and Python, and it works from the start with PyTorch, NumPy, and all the different packages that you probably already know. And this is very simple, and it's zero copy as well, so it's very performant compared to if you use ROS2 or something like this. And in fact, we do a lot of benchmarking, and when you look at benchmark, if you use ROS2, you might have up to 20%, 20-time increase of speed, because we have no serialization, no deserialization, and all the packages can already use Dora from the start. So, okay, so let's talk about how can we train a deep learning model and how can we infer it with Dora, right? So the idea is that we want to make it extremely simple so that anyone can get started, right? And if you've been following, so the first step is to do data collection, and so we can create a data set so that we can train a model on, right? So at Dora, we really want to make it super simple. And to make it super simple, we just want it to be a one-line flow that we can just start, right? So for example, I'm going to say, okay, Dora, start Quant VL2 recorder, which is the step that is going to be able to record data for me. What is going to happen is that I'm going to have the demo, and then I'm going to be, what I want to do is give him action, record it, so that I can just train my model on. And so in this case, I'm going to teleoperate the robot with my keyboard, which is very accessible because anyone who has a computer probably have a keyboard. So if I touch my keyboard, I have like predefined movements. So if W is forward, S is backward. So if I type on W, it's going to go forward. If I type A, it's going to go left. D, it's going to be right. And then I can also move the hand as well. So I can close it with T. Come on, close it. Right, the hand sometimes doesn't close, but it's something that we're going to fix. Then I could go down. I can go forward with the arm, I can go backward, I can go left, I can go right, I can go any direction you want, right? And the thing is that anyone can get started with this and try to collect his data, right? And once you collect the data, you can just train a model on, as I said. So it's super easy. In that case, I'm using like a community-based deep learning model trainer, which is called Llama CLI. And so once I have collected my data, I can just stop it, and then I'm going to bring my Llama factory model. And so then I can just say, okay, train my models I just got my data on. So here I can specify which path I want to use, and then I can say, okay, use Dora demo 208, for example. And then I say, okay, train it. And then he's just going to train, and everything is already prepackaged, so that you don't really have to think too much about the path and think about, oh, how can I, how should I install it? So everything hopefully should be just one-liners everywhere, and at the end I'm going to get a model, right? So training the model is a bit long. It takes about, in this case I have 150 images. It takes about 15 minutes. But if I have a very complex case with a lot of movement, it can take about hours and 2 hours, so we probably don't have time, and we probably don't have time to this talk, so I'm just going to skip it. And I already have built a very small data set of images. Where's my, okay, here it is. And I'm just going to show you real quick. If I can move my keys. Okay, I can't move my keys. Okay, I'm just going to go on 208 here. And so I just made a quick demo data set where I'd say, Okay, grab a bottle. Today we're not going to do a grab a bottle, but basically I did a quick data set, and I say, okay, if you should go left or you should go right, and now and the image is basically me. So can I open it? Yeah. Dora demo 208, and then, okay, sorry. So I think okay, I think I can't open it. Oh, it's fine. So basically the image looked like, do I have it? Ah, fixed. Wait a minute. Okay, if I do this, if I do this, if I do this, so basically I'm gonna get image like this, which is just me. I just did it outside. If you were looking at me struggling, this is me building a data set. And I trained a model on this data, which is just me on the left side, on the right side, just to showcase that after this finish, so basically this is what's running, I get a model, and then this model I can infer it with Dora, like this. I can say Dora, Quenville to robot infer, and then it's going to start to do the inference. And in this case, my prompt is to follow the man with the tie, which is me, and now he should start following me, right? And so if we go too far, hopefully he's going to start to go left, and then he go back, right? And so in this case, I think there's people behind me, so he has a bit of trouble, but the idea is that so this is purely trained on the data I have right now, so maybe I'm just going to catch him real quickly. And in the future, we hope that we can train like more complex data, right? More complex model, but this very simple basic step can scale, right? Because it's a VLM, as you probably used ChatGPT before. This very simple demo can scale to a lot of actions, all of the actions to the arm, all of the actions to do more complex things, right? And so I'm going to stop this right now. Okay, I'm going to stop this. And so once we have this, we can train the model, we can generate the model, we can infer on it, and when we infer on it, we can also create a leaderboard, right? The idea is that we probably want to know, everyone will have some form of model that he wants to share. The idea is how can we compare them, so we can also build leaderboard on this, right? Okay. So for example, I have a more complex demo that I can show you in my screen. So with like a humanoid robot, and what we did is just collect a lot of data, as I've shown you before. And it doesn't take a lot of time, it takes about a day. And then, for example, in this case, I want him to do a high five. And so I took a lot of data in different situations with the robotic arm, in the same way that I could have done in this case with my keyboard. And then, after training, he's going to be able to do some high five, right? So this method scaled from this robot to different type of humanoid, right, as well. And so hopefully he should be able to start doing high fives to me. We have a even more complex demo about, about hair, which is about, in this case, we took more data, about a week of data, and then, for example, we can grab a cup, and we can also grab an apple, and then give to people. And in this case, we have both manipulation, we also have a bit of navigation, so the robot is able to rotate. And so we can really scale into all the different problems of robotics instead of having to focus on like manipulation first, navigation second, and things like this. Okay, and so that's our humanoid robot demo. But the thing is, now we're thinking about, okay, so we did all those demonstrations in labs, and we know that they work, but hopefully we can make maybe more of this, right? Because sometimes if I do a quick demo here, it's going to work, but probably if you use it at home, it's probably not going to work. And the idea is that maybe what we're doing is trying things that only works on labs, and maybe we should try things that is different, right? So trying to solve real problems. And so I think we have all the tools to actually solve all the real world problems. So for example, I can give you one example, is that we can actually think about how can we actually feed people, right? Feed disabled people, people that actually really need help. In this case, there's a lot of people who can't use their arms, but they need to somehow get fed, right? And so we can actually use a robot like this and just like grab food and put it on their mouth. And this doesn't really cost much, but it can be very valuable for those people or for like elderly. And we really think that we want to tackle those issues. Another example is cleaning trash. So in Beijing, it's fairly clean, right? But if you go to Paris, you'll see that it's fairly dirty. And so, yeah, because the cost of labor is super high, it's one of the most visited cities in the world, and so you have a lot of tourists, so you probably need to clean it very oftenly. And all you need to do is basically just grab trash on the street and just put it in the bin, and that's it, right? The intelligence is fairly slow. What you need is a bit of intelligence so that you can navigate a bit and like avoid like taking things that should not be taken or things like this. And we think that a solution like this could definitely do it, right? We have all the tools. Now we just need the data and a way to train the model, and that's basically it. And we can basically build one in some ways. And so what's our plan? Our current plan is that we have a hackathon actually going right now at the moment at GOSIM. We have about 40 students that is really working on, can they find a good way to collect data, train a model that is not overfitted on distribution. And we have a couple of universities that is joining us, Chongqing, for example, that have been helping me, for example, for this talk as well. And we have Beita from Beijing, we have Tsinghua from Beijing as well. And hopefully we can have a European university in the future. And so we're really like thinking, brainstorming on how can we make this the most efficient way to build a model that can really solve, for example, the trash problem, right? And once we're sure about how we're going to do it, hopefully we can train it on real-world data with more scale, with more people, and then hopefully we can do some form of open source release of a model. And hopefully this model should work on any type of robotic application, right? On any type of robot, right? So not just this robot, but any robot you can buy at home. All you need is 2 cameras and a way to control the robot, and hopefully it should, from the get-go, be able to clean up trash or feed people in different ways, right? So that's about it. And so if you have any question, feel free to ask, and I'll be around. I can stay around this afternoon as well a bit if you want to talk more about data collection, training, inference, or anything else. So thank you.
Yeah.